Hi friends, in this video let us see superheterodyning. We all know that this is a very important topic asked in a GATE exam or any competitive exam. Let us understand this topic very clearly. Right? Whenever we study communication engineering, especially about receiver, what we do is we always shift or translate incoming signal frequency. What is there is a incoming signal of any receiver? It is a modulated signal, right? So incoming signal frequency, it is a modulated signal. Modulated signal is having a very high frequency in the RF range because we modulate with the carrier, which is a very high frequency signal. So what we do is we shift or translate that modulated signal frequency into new center frequency, right? So new center frequency, which is known as intermediate frequency, right? So intermediate frequency IF, right? Normally we know it is RF frequency in megahertz, it will be in megahertz. Normally the intermediate frequency will be in kilohertz. So in this range only, after shifting this only, what we do is we do amplification. In receiver side we do filtering and demodulation. So we do all the process in the IF range. We never do all the process in the RF range because it is costly and not economically feasible, and so many technical reasons are there that we study deep in the superheterodyne receiver. Not now. Okay, so what we do, the main thing we are doing in the receiver side is RF frequency is shifted to IF frequency. This is achieved by the phenomena called heterodyning or mixing, right? Okay, let us see how this is carried out. Okay, so this is my incoming signal frequency, so it is RF, right? So once it is received here in mixer, what we do, we have one device called mixer where the frequency from the local oscillator is mixed to achieve this intermediate frequency. So you know all this is the other block. So it is a total superheterodyne receiver. I don't have explain this about this block. We are bothering about this area only. So here we have to work with intermediate frequency. That's what our mode. Here we have a amplifier will be there, and a filter and a demodulator, all the things will be there. So total this is a super heterodyne receiver block. This is a heterodyning area. So we bother about this only in this video. Okay, fine. So now you see, so I want to convert this RF frequency range and translate this RF into IF range. So what we are doing, this is achieved by having a frequency difference of, this is, let us assume this is the frequency of the incoming signal is Fs. So Fs minus FLO, the frequency from this is FLO, local oscillator frequency. The magnitude difference should be equal to FIF. So it is like tuning our radio receiver in FM. So we receive the signal from the FM station, right? So every station is allocated to some intermediate frequency. If you tune our tuner, that is what our local oscillator, if you tune this according to this range, we will receive the signal. That's what this one. So the magnitude difference between the signal frequency and local oscillator frequency must be equal to FIF. In this way, RF, this is Fs is RF range, this is converted into IF range. So if I simplify, what will happen? Fs minus FLO is equal to plus or minus Fi. Clear? So because it is magnitude, the difference may be either plus or minus. So this indicates FLO is equal to Fs minus plus FIF, right? So my FLO will have two range. Either it may be, the result may be, I can tune to Fs plus FIF, or FLO range may be Fs minus FIF, right? So if I tune my local oscillator to this condition, then it is called high side tuning. High side tuning. If I tune my local oscillator to according to this formula, then it is called low side tuning. Let us see what will happen in high side tuning and low side tuning. So first we take high side tuning HST. So here we know FLO is equal to, for high side tuning, FLO is FS plus FIF. This indicates, what is the thing we are understanding? FLO is greater than FS. So local oscillator frequency is greater than signal frequency, because FLO is FS plus some other frequency. So some will be greater than this FS. So for high side tuning, my local oscillator frequency should be greater than signal frequency, incoming signal frequency. Otherwise, signal frequency should be lesser than local oscillator frequency. If they give the condition like this, we have to use this formula. This is what we have to remember. So this indicates here in high side tuning, local oscillator frequency is greater, which is then signal greater than Fs. Fs is greater than always incoming intermediate frequency, because it is a RF frequency. It is in RF range. Incoming signal is RF. So in that we are adding something, means it will be in RF, but it is in intermediate. So this is the condition for high side tuning, right? But so if I tune like this, what will happen? So if I have high side tuning, my local oscillator frequency is Fs plus FIF. Incoming frequency is Fs, the local oscillator intermediate frequency is FIF. So this is incoming, this is local oscillator, this is intermediate, which is represented by the equation Fs minus FLO, right? So if I do this, then I get this operation, FIF, right? This is the way I have to tune. Fs minus FLO is FIF. That's what we have known this, right? Fs minus Fs minus FLO is FIF. That is what my intermediate frequency formula. So this is what we have done in the high side tuning. So this we must do. But what is the problem here is, so this is the frequency allocated for every channel. Suppose if for some other frequency, Fs incoming signal is having a frequency like Fs plus 2 FIF for high side tuning. For high side tuning, local oscillator should be always equal to Fs plus FIF. So instead of this signal, if this signal comes to the receiver, what will happen is, this is a signal for other channel. So if this signal comes to here, is what is intermediate frequency? Fs. This is what Fs value. So Fs is Fs plus 2 FIF. What is FLO? FLO is Fs plus FIF. If I subtract, what I get is FIF. So I get the same intermediate frequency. But my receiver should receive this Fs only. But if some other frequency of Fs plus 2 FIF will also come, means my receiver will tune to this range also. So what is happening? This will create an interference and the receiver will not perform properly. So what is the thing here is, this frequency is the image of this frequency Fs, because both are creating the same FIF. That's why it is called the image frequency. So for high side tuning, image frequency is Fs plus 2 FIF. This is very, very important. So here always local oscillator frequency is greater than Fs, signal frequency. So this we must know. Local oscillator frequency is greater than signal frequency. So in exam they will give the condition whether local oscillator frequency is lesser than signal frequency or greater than signal frequency, whether it is high side tuning or low side tuning. For all the things you use this formula. Suppose if you use low side tuning means what? We understand low side tuning means we know for low side tuning, you see FLO is Fs minus FIF, right? So FLO is Fs minus FIF. This indicates here Fs is greater than FLO, because FLO is Fs minus some other thing. So Fs must be greater than FLO. So this indicates here Fs must be greater than FLO. Both are greater than FIF. So this is the condition for low side tuning. This is very important condition. In exam, we have to bother about this. There is the twist in will be in the question, right? So if incoming signal frequency is greater than local oscillator frequency, means I have to use this formula only to find the local oscillator frequency, right? Okay. So, but now we understood the same table we will put for low side tuning. What is incoming frequency? Fs. Local oscillator frequency Fs minus Fi, because I use low side tuning for local oscillator frequency. Here what I get is Fif. What is the formula for this? Fs minus Flo mod. Suppose here some other channel with the frequency Fs minus 2Fif comes, I use low side tuning only for my local oscillator. This is Fs minus Fif. So what will happen? I substitute this value. Fs is nothing but Fs minus 2Fif. Minus of Flo is Fs minus Fif. If I subtract, so what I get is, it is minus Fif. Minus Fif. If I take magnitude, what I get is, it is Fif. So what is the problem? Both the signals are producing the same intermediate frequency. So it is this is the image of this one. So because the receiver will get corrupted. So what is the thing is, for low side tuning, Fs minus 2Fif is the image frequency of the original signal. So if the question is given for low side tuning, we have to use this formula, right? So this is what we have to understand, right? So please be careful about this condition, right? Now let us solve the problem. Okay, where is the problem? Okay, let us see this. Here you see, for a super heterodyne receiver, right, the intermediate frequency is given. So what is intermediate frequency? Fs is 15 mega, sorry, intermediate frequency is Fs or Fi. So intermediate frequency is 15 megahertz and the local oscillator frequency Flo is 3.5 gigahertz. Right? If the frequency of the received signal is greater than local oscillator frequency, what is the condition they are given? Fs is greater than Flo. Incoming signal is greater than Flo. What is image frequency? That is what they are asking. So they have given the condition Fs is greater than Flo, means it is low side tuning. Just now only we saw. So low side tuning. For low side tuning, what is the equation? The equation is, what do you call? It is F signal or Flo is equal to Fs minus Fif. Right? So they have given Fif value. Fif is 15 megahertz minus Fs. Flo value is 3.5 gigahertz or 3500 megahertz. 3.5 gigahertz is nothing but 3500 megahertz. Right, from this what I get? From this I get Fs equal to 3515 megahertz. So signal frequency I got. So what they are asking? They are asking the image frequency. For low side tuning, what is image frequency? For low side tuning, image frequency, just now only we saw, image frequency is Fs minus 2Fif. That is the formula. So Fs is 3515, F2 into intermediate frequency is 15. So 3485 megahertz. Right, this is what my image frequency value. Right, so the thing is, you have to see the question properly, right? Kindly give attention to the condition. So normally they won't give this condition. If they give, we must be very careful. So normally what we do mistake is, we always prefer I-side tuning, right? By using Fs is great, we use this formula, but that should not be the case. We always use this formula only to find the image frequency, but we must watch the question carefully, then we have to solve the problem like this. Okay, I hope you understand this problem, right? So please give importance to the condition, right? If you have any doubt, please ask me in comment section, I will clarify. Thank you.